Hey guys, we're looking at solving equations graphically, and so we're going to look at a couple examples. One that's been already been sketched, and I guess the purpose of it, and then we're going to put one into practice, and then we're going to finish off with a problem-solving question. So we've got a graph here, which is 3x plus 2y minus 8. And so what I might do is just highlight these so it's a little bit more visual. So we got 3x plus 2y equals 8. And then we also have one that is y minus x equals 4. And without getting through too much of it at the moment, because I've got some on the right hand side that we can sketch together, obviously we remember that our linear equation structure is y equals mx plus c. M is your gradient, c is your y-intercept. Okay, so we can rearrange things. For example, this one, we can still have y is equal to, and that negative x we will move to the right hand side of the equation by adding x to both sides, so keeping things balanced. So we will have a positive x plus 4. Still the same thing, we've just rearranged it so it fits the same structure of our linear equation. We have our gradient as 1 and we have our y-intercept as 4. If we were to look at the other line and rearrange it, we'll start with 3x plus 2y is equal to 8. We're going to move the 3x to the other side by subtracting 3x. So we have 2y is equal to minus 3x plus 8. And then we need to divide both sides by 2, which gives us negative 3 over 2x plus 4, because 8 divided by 2 is 4, minus 3 divided by 2 is minus 3 halves. Okay, so we can say that this is the rearranged formulas for each of those equations. So this one corresponds to that, and then our other one corresponds to that there. Okay, now looking at the graph, they've already sketched it for you. The whole purpose of this is to work out where the point of intersection is. Okay, so the point of intersection is where the two lines meet, and the two lines meet here. Okay, so I'll just put point of intersection is 0 and 4. Okay, so where those two lines actually meet and cross over each other, where they intersect, is at coordinates 0 and 4. And so looking at this second one, we can see that the point of its intersection is here. So point of intersection is, again, we don't have to do any solving. That'll be for another time. But all we require for you right now is to be able to sketch the graph and then see where they cross. And at this point, it is negative 2 and y is negative 4. Okay. We can rearrange the equations if we want to again. So this one over here, rearranged to fit the structure, would be y is equal to 3x plus 2. That is a negative 3x, so we moved it to the right by adding 3x. Then the same thing with this one here. We want to make y positive, so I'm going to move that across to the right hand side by adding y. So we'll end up having x equals y plus 2, and then I need to move the 2 across to the left hand side to make y the subject on its own. So we'll end up having y is equal to x minus 2. If that makes sense to you, I'm hoping it does, because we've been through balancing equations, rearranging linear equations through algebra, and that's essentially what we're doing in this chapter, just so it forms the subject of y is equal to mx plus c. Okay, So we're going to put this in practice now. We've got two linear equations on the right with this bigger Cartesian plane, and we're going to sketch each of those. And whichever format, whichever method, gradient intercept method, x and y intercept method, there's two forms, and we'll do one of each, okay? So I'm going to use the gradient intercept method for this one, and I'm going to use let's just erase this, x and y intercept method with the second one, okay? So with number one, we know that the gradient is 2 over 3. So 2 is your rise and 3 is your run. So because 2 is positive, we're going up, and your run is always going to the right. It never goes to the left, okay? We know that from looking at the graph, from the equation, sorry, that is your y-intercept. So that ticks off the I, okay? So let's put that in. So 2 is over here. Okay, remember this is your origin right in the middle. I'm not going to annotate that. So that will be our starting point. Using the gradient method, I'm going to use this point to go up 2 points and then 3 across. So up 2 points and 3 across. 1, 2, 3. And there's our next one. And just thinking of a staircase, up 2 points and across 3, there's our next one. Up 2 points, across 3, there's our next one. And we can backtrack again. We can go back 3, down 2. Back 3, down 2. Back 3, down 2. And we can just keep on going. And it's clear that it is a straight line. Let's just jot that or join the dots together. That looks all right. Okay, so there's our first graph. And with our second one, we're going to use the x and y-intercept method. So y equals 2x minus 2. The y-intercept is always the same thing, okay? So y-intercept is minus 2. So minus 2, the graph is going through there, okay? To get the x-intercept, you want to make y 0. Make y equal to 0 and solve for x, okay? So we've got 0 is equal to 2x minus 2. We're going to move the negative 2 across to the left by adding 2. Remember, we're balancing equations here. So we'll end up getting 2x is equal to 2. And to get rid of the 2, to get x on its own, we divide both sides by 2. And therefore, x is equal to 1. Okay, so x is equal to 1. That is our our x-intercept. Our x-intercept is here. Okay, so let's graph this, put this together. I think that's straight enough. Yep, we'll keep going and going across. There we go. And we can see that the point of intersection, and I'll use a different color here, the point of intersection is right there at x is 3 and y is 4. Okay, so that's how you solve equations graphically. And so we've just put everything together in terms of y-intercept method, the gradient intercept method, the x and y-intercept method, solving equations algebraically, and balancing the equations. I want to now finish off with a problem-solving question. and see how you go with, I guess, understanding context, understanding a story, and picking out the points that's really important to you. Okay, so here we go. A fire truck and an ambulance have been called to an accident scene. The ambulance starts at the hospital, and the equation of the distance it travels with respect to time is d is equal to 1.8 t. Okay, the fire truck leaves the garage and travels. Following the equation, d is equal to 1.5 t plus 3.6. In both equations, d is the distance traveled in kilometers and t represents the time in minutes. Okay, so first thing, d is distance and t is time and in minutes. Okay, so I've highlighted the things that I need and I've jotted down some points that I need to understand as well. And distance is in kilometers. Okay, first thing, plot the two graphs on the same set of axes, with D on the vertical axis and T on the horizontal axis. Okay, so we know that this is time and this is distance. Yep. How far from the hospital was the ambulance after 5 minutes? And if the two vehicles meet at the scene of the accident, how long did it take for the two vehicles to arrive? What distance did the two vehicles travel to the scene of the accident? All right, let's just work with one equation first. So we'll work out d is equal to 1.8t. Notice that there is no y-intercept, okay? The y-intercept is actually 0. So we could say that that first equation, okay, being in red, it goes through the origin. And now we need just always 2 points to make a straight line. We need to work out what the second point is. So we've got 1.8 as our gradient. Okay, so 1.8 is our gradient. And we can convert that into a fraction or an improper fraction. Notice that it's over 1. And so we're looking at 1 and 8/10, or we could say this as 1 and 4/5. Okay, so that's a mixed number at the moment. So we're looking at 9/5 as our gradient. Okay, so 9 is the rise and 5 is the run. So going from this point here, we're going 9 up, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we're going to go 5 across, 1, 2, 3, 4, 5. So there's our second point there. So what I'm going to do is I'm going to jot those 2 points. So there's our first graph. It's straight enough. And then we're going to move on to the next one. Okay, so we've got D, and I'll make that green, is equal to, so D is equal to 1.5t plus 3.6. So 3.6 is our y-intercept, and so it's a decimal. So 3.6, so we got 1, 2, 3, that's a 4. So I am doing this, I guess you would want something a little bit bigger, but for this particular moment, I'm just eyeballing it. And 1.5 is our gradient. So 3.6 is our y-intercept, and 1.5 is our gradient. Okay, so 1.5 is also 3/2 as a fraction. There's our rise, and 2 is our run. Okay, so 3 going up, so 1, 2, 3, and then going across 2, 1, 2 is about there. Okay, so our second point is we could say that this first point is 0, 3.6. Let me just make that neater. 3.6. And this one is going to be 2. And then because we moved up 3, 3 plus 3 is going to be 6.6. All right, so let's jot this down, okay? So looking at the graph, we could see that the graph is, both of these graphs, they're very similar to each other. This one's just slightly not as steep as the red one. So I want to show you how we can, we've done A. We've plotted the two graphs, okay? And we can see that I've ran out of space where they can't join each other, and it's off the charts. So let's look at what are the questions really asking for. How far from the hospital was the ambulance after 5 minutes? Okay, so the ambulance equation is this one here. All right, so if we're looking at this, we've got D is equal to 1.8 T. And the first question asks when T is equal to 5, what is the distance? Okay, so let's substitute 5 into T. And so we go distance is equal to 1.8 times 5. And we'll end up getting 5 times 1 is 5. 0.8 times 5 is 4. So we've got 9. So the distance is 9 kilometers. If the two vehicles met at the scene of the accident, how long did it take for the two vehicles to arrive? Okay, what distance did the two vehicles travel to the scene of this accident? So this is where we get a little bit creative here. We are working with decimals, not numbers that we're comfortable with. But if I rewrote the two equations, we got D is equal to 1.8 and D is equal to 1.5T plus 3.6. We want to know, what's the question? How long? We're asking for time here. And then if the distance is going to be the same, then each of these is equal to D, right? So that means if these two equations are both D, we can say that 1.8T is equal to 1.5T plus 3.6. They are equal to each other because they are both equal to D. So now what we can do with this, we can actually say, well, what is the time? We can solve for T by just solving the linear equation. So we're going to take away 1.5T from both sides. So 1.8 minus 1.5 is 0.3T is equal to 3.6. To get rid of the 0.3, we're going to divide both sides by 0.3. And I'm happy for you to get a calculator out. Let's move this across. So 3.6 divided by 0.3 is 12. Okay, so the time for them to both meet at the scene of the accident is 12 minutes. Okay, now we've done C. The question is now, what distance did the two vehicles had to travel? Okay, so let's work that out. So to get from, let's work out with the ambulance first. Back to the ambulance. we've got d is equal to 1.8t, and if the time it takes to get to that place is 12 minutes, so go 1.8 times 12 is, where did my calculate? There we go. So 1.8 times 12 minutes is 21.6 kilometers. So 21.6 kilometers is the time for, or the distance that the ambulance traveled. And then for the truck traveled was d is equal to 1.5t plus 3.6. So we can then say 1.5 times 12 plus 3.6 is going to be the distance of the truck. So let's get the truck out, and we'll go 1.5 times 12, that is equal to 18. 18 plus 3.6 is equal to 21.6. Okay, so they both traveled 21.6 kilometers to get to where they need to be, and they both took 12 minutes to get there. Let me know if you have any questions, and happy to help out. All right, have a good one. See you in the next one.